I thought that was a great talk that Tom just gave. I really appreciate that. It really set the context for some of this other work that we're doing on Cisco species flock as well. My name is Seth Moore. I'm proud to be an employee of the Grand Portage Band of Lake Superior Chippewa. And I just wanted to start by saying I feel a bit like a rock star today. Not half an hour ago, I was giving a talk for the Lake Superior work group on moose and climate change, and then I was whisked in a black, shiny SUV with myself as a chauffeur to come and give a talk here in front of influential and bright people. But more importantly, I feel like a rock star because I was fortunate to work with Dan Yule on this project, who's a self-proclaimed Brad Pitt of Lake Superior fisheries research. So I'm going to talk a little bit about some morphometric work that Dan and I took the lead on in the last several years. We've worked with some other rock stars like Tom Pratt, Mark Ebner, Randy Claremont, and Winnie Stott. The first part of our study began 3 or 4 years ago. We wanted to identify whether two different forms of Coregonus artidae, or Cisco, existed in Lake Superior. Historically, there was this form called the reef herring, and then there were the traditional pelagic form of Cisco as part of a species flock that Tom just referred to. So several different stocks historically existed. These were defined initially by a guy named Keltz in 1927. These Cisco species flocks stocks were systematically depleted through the 1940s and 60s due to overfishing. A number of different folks have written about that. More recently, we're seeing strong and significant evidence of recruitment failure in the Cisco species. And so what we were asking was whether or not these Lake Superior reef herring made it through this bottleneck of recruitment. And we thought this question was important in light of the interest in restoring Cisco species to the Great Lakes. Some of the historic species stocks were identified by Goodyear in his 1982 spawning atlas, and you can see here by this image that this is an interesting one to look at. This is a pelagic stock, and then here are some of the reef spawning stocks. USGS, oops, I haven't got there yet. This is a pelagic stock. USGS and some of their recent spawning surveys using hydroacoustic gear have also found similar aggregations of fish during spawning periods. This corresponds possibly to that pelagic spawning stock, and here's some nearshore stocks as well. So our objective, as I mentioned, was to determine if this reef herring still exists in Lake Superior and whether or not we could detect it. We used some Truss morphometric methods that have been described extensively in the literature. These are the similar methods that were used in Moore and Bronte in a 2001 paper looking at lake trout in Lake Superior. We photographed these fish, we measured them, and then we did some analysis on them to determine if there were shape differences that were present in the different forms of fish. So we collected fish from different locations in Lake Superior where we knew there were pelagic spawning stocks, here in the Apostles and also in Thunder Bay region. And then we collected some fish from some historic reef and shoal spawning strains as well, St. Mary's and in Grand Traverse. You can see here that the sample sizes are generally unbalanced across these sample sites. What we did to deal with that was we did a random selection through the data set so that we had approximately equal sample sets from each location. I'll skip quickly to the results. The analytical methods are well established in the literature. I will say this: we use conservative methods to determine whether or not these shape differences exist. And here I indicate two different forms of results to validate what we found, but I was very pleased with the results. We found about 98% classification success using a cross-validation procedure for the pelagic spawning fish, and about 98% or 99% correct classification rates for a reef spawning form as well. An independent measure of this was done using principal components analysis, which doesn't use the a priori classifications. Again, we found very good separation from the two different strains of fish. This was very enlightening to me and very powerful because these were probably the cleanest results I'd seen doing this type of analysis in a long time. There's actually a 95% multivariate mean, which is a very small ellipse in these points that shows how tight the variability was in here. Then we take, the next step is looking at what body regions are different in these pelagic spawning fish and the reef spawning fish. And what we found was that the reef spawning fish tended to be deeper bodied in almost every region of the body, whereas the pelagic spawning fish tended to have longer head measures and then some longer tail and caudal peduncle measures as well. So here's some images of the two different types of fish. You can see clearly that these reef spawning fish much deeper bodied than the pelagic spawning fish. So this gave us some information to come to the conclusion that in the Coregonus artidae species group, there may still be some variability among these different stocks. So I mentioned that I was fortunate to work on this project, and I'm working with the Brad Pitt of Lake Superior Fisheries Research, but in addition to having a pretty face, he also has a few good ideas in his head. And so Dan came up with an idea to look at Keltz's data and determine whether or not Keltz was a good taxonomist. And so for context, we talked about the different species. Keltz identified 8 different morphotypes within Lake Superior Basin. And these populations have suffered multiple different insults that we talked about. Stockwell talked about them, and Selby talked about them as well. But we have some strong populations here in the Lake Superior in particular, and some strains in Lake Huron as well that we wanted to look at. And so given the interest in potentially listing the short jaw cisco and the interest in restoring cisco species to some of the other Great Lakes, we wanted to really see, first of all, if this taxonomy was real, and then second of all, if modern cisco species corresponded to any of the pre-existing cisco species that Keltz identified in the 1920s. Keltz was a very good scientist, and he was also a very good drawer, or a very good artist. These are some of the forms. I'm going to talk primarily in the first part of this discussion about these 3 forms within the Coregonus artidae complex. Whoops. And then I'll move briefly into some discussion on some of the other forms of Coregonus kai, hoyi, and Xenithicus. But to determine whether or not Keltz did a good job could have been a challenging assignment, except for the fact that Keltz put his raw data into his manuscript. And he included different metrics for separating these fish out, including a bunch of different landmark ratios, some scale counts, fin ray counts, gill raker counts, and then some more traditional fish measures. But one of the nice things about giving us this opportunity was Keltz did not test his data statistically. So this is like putting a ball on a tee for a person that likes to do multivariate statistical analysis. So our objectives were to apply some modern statistical techniques to Keltz's data to see how good a job he did at identifying different forms of fish. And then ultimately, if he was able to do a good job at identifying these different forms of fish, we wanted to see if some of those forms existed in our modern day cisco species. So the methods that we used, we re-entered Keltz's data into a computer. We recalculated a number of his ratios, turning them back into traditional measures or to straight measures because it was easier to analyze that way. We used a size-free discriminant analysis, which is similar to the analysis that was used in the first part of the study with the reef spawning form and the pelagic spawning form. We had really nice sample sizes. We looked at about after building the model on Keltz's data, we looked at about 1,800 cisco from around a number of different Great Lakes sites. And then we looked at using these body measurements through the discriminant function analysis to see what cisco forms presently exist in the species that we caught in modern day times. This image indicates some of the measures that we used. Here are the sample locations from which we caught modern day fish, and the sample sites, which are in relatively small font, but they're pretty decent sample sizes. So I'll just jump right into some of the analysis. First of all, when Keltz collected his data, he used some measurements and he used some heuristics or some body counts. And so we wanted to evaluate whether or not he did a good job at identifying these different species forms, and then which was better, whether it was measurements or whether it was these heuristics or whether it was both. What it comes down to is that Keltz is a very good taxonomist. And no matter what measure that we used, we were able to classify out the fish that he had identified, those 9 different forms, very effectively. Using both measurements and heuristics with the cross-validation classification, we got almost 100% classification rates. Using heuristics, slightly lower, or using measurements independently, was slightly lower, but using a combination of these variables was very, very effective. Also, in building the discriminant function model, we got two different regressions, essentially, 2 different canonical coefficients, sets of canonical coefficients to classify these fish. And so here's how the 3 primary species of Coregonus artidae separated out on 2 different canonical axes. The important thing, so these are Keltz's fish, how well they separated out. They had 90-some% classification rates. But the important thing to keep in mind from this image is the location of these different centroids. So artidae here on the left-hand side of the 2 axes, somewhat central on the second axis, in black. Albus, lower and right, and Manitoulin is upper right. Again, here are his classification rates, building the model just on Keltz's fish for these 3 different forms of Coregonus artidae. So 86, 95, and 90% correct classification rates with a cross-validated model. So for the purpose of this talk, we're just going to indicate one of the locations. This is or 2 of the locations, I'm sorry, in Lake Superior. But the Grand Portage fish and the Thunder Bay fish all classified out in this black area, which is where Coregonus artidae. This is using the exact model that was built on Keltz's fish. So this table indicates where all the other locations from Lake Superior, how those fish classified out. Essentially, the majority of Lake Superior fish classified out as Coregonus artidae, with the exception of 2 locations, northern Black Bay, northern Nipigon Bay. In those 2 bays, Keltz identified this albus form in his paper and said that, Coregonus albus exists in northern bays and on the Canadian shoreline of Lake Superior. We found at least some evidence that that form might still exist up in these 2 bays, but for the most part, Lake Superior artidae classify out as they should as artidae. When we plugged in Lake Michigan fish and Lake Superior fish into this canonical model, there's a high degree of overlap. So what it looks like is Lake Michigan fish and Lake Superior fish all tend to classify out basically as artidae. However, when we look at Huron fish versus Lake Superior fish, we see a significant difference here. It looks like, if you remember that initial plot with the canonical axes, these fish are coming out somewhere in the vicinity of Albus and Manitoulin, whereas the Lake Superior fish, as I mentioned earlier, are all classifying as artidae. So when we ask the question, do some of these historic forms persist, and if so, where do they persist? Well, what we found, we're in the Lake Superior locations, we tend to see artidae. Drummond Island Huron in Lake Huron and North Channel in Huron, we tend to see fish classify out as albus. And then the St. Mary's River, we see this species that doesn't really classify perfectly as either albus or Manitoulin, but it certainly is not classifying out as artidae. These are the 3 different forms that I just talked about. These are Keltz's drawings of them. So Lake Superior fish, you can see just from a photographic image of one of the fish that we used in this analysis, clearly looks like an artidae. This is from Devil's Island in Lake Superior. Grand Traverse Bay also classifies out as artidae. It's slightly deeper bodied, but it doesn't seem to resemble the albus or the Manitoulin forms. Drummond Island, I think that's a pretty compelling image of the resemblance between albus and the cisco that was caught there. These are the St. Mary's River fish. They were somewhat ambiguous between albus and Manitoulin, which is indicated by this positioning on this graph, but it's clearly not a traditional Coregonus artidae. So with that, we were able to conclude reasonably that at least different stocks of Cisco are likely to exist in Lake Superior and in the Great Lakes. And so in light of restoration efforts, those different forms may want to be considered in terms of restoring some of the lower Great Lakes. But I also thought it was important to try to use some of this from a practical in a practical application to fisheries biologists and managers. And one of the things that fisheries biologists like to do in Lake Superior is to classify out the different forms that exist, which we know are Artidae, Hoyai, Kaiai, and Xenithicus. And the measures that fisheries biologists really like to use are these distances between the pectoral fin and the pelvic fin, and also this distance between the pelvic fin and the anal fin. And it's sort of widely known that Artidae has a long gap between those two fins, whereas Hoyai and Kaiai have much shorter distances. They have much longer fins relative to their body size. We wanted to see how good a job just those two measures did at classifying out the different species that presently exist in Lake Superior. And what we found was when we used all of those heuristics and measurements that Celts used, we could classify all 4 species with 100% classification, 100% classification success. They were very good using multiple variables. When we used just those 2 different measures, when there are only 3 species to consider, Artidae, Hoyai, and Kaiai, we also got really good classification rates. Those 2 measures work quite well on these 3 species. But when you throw Xenithicus into the mix, there's a little bit more ambiguity. And I show that here with this image. So Artidae has this long distance. They have short fins. Hoyai has an intermediate distance. They have intermediate length fins relative to Hoyai and Kaiai. But Xenithicus also has these intermediate length fins, which provides this ambiguity, whereas Kaiai have very long fins. They have a short gap between those 2 different fins. And so that's indicated here by these classification rates. Classification's correct. The successful correct classification falls apart a little bit when you throw Xenithicus into the mix. So these are good measures to use from a practical standpoint, but you're going to have to do something different when you're looking at Xenithicus. So in summary, the Truss morphometric analysis that we did initially certainly indicated potential for presence of a reef spawning form outside of the Lake Superior Basin. I think we can safely say that Celts was a good taxonomist in addition to being a good artist, and maybe using his taxonomy as historic forms is probably a good thing to do. The present day forms of Artidae tend to resemble Artidae albus and Manitoulonus. Certainly in Lake Superior, Coregonus artidae seems to be the dominant form. With the 3 Lake Superior forms, using those 2 measures works relatively well, works very well, but with 4 forms, with Xenithicus into the mix, it tends to fall apart. We also think that multiple forms that exist within the Great Lakes Basin offer some possible restoration choices for Cisco efforts in the Great Lakes Basin. Moving forward from this, we're very prolific in terms of generating ideas and trying to do analyses. We're currently processing some genetic samples from Lake Michigan. We're working with Wendy Stott to do genetic analysis. She's doing some work similar maybe to what Tom Pratt just talked about, where we're comparing side-by-side morphometric work and genetics to see how well shape differences correspond with genetic differences. We want to analyze for stock discreteness. Dan wants to analyze for stock discreteness in these Ciscos using a number of different factors, including morphometric information, genetic information, and maybe some isotopic differences in terms of what they eat. We're trying to see if there may be some trophic niches may exist in the Cisco species flock. And lastly, we've just landed a grant. Dan has landed a grant titled the Student Intern in Support of Native American Relations, SISNAR. This is the second time we've landed this grant, and this person, once we hire this person, will help to do some of the data measurement so that we can analyze these fish. So I have 23 seconds left for a question.